Hello, welcome to this video on reviewing Chapter 1 material for geometry. Do is just kind of whip through a brief overview of what we're going to do. So we'll talk about intersecting planes, go on to some intersecting lines, talk about some of the angles formed by intersecting lines. We'll solve a problem using the angle addition postulate, midpoint theorem, segment addition postulate, and talk about angle pairs again, and then end up with distance and midpoint. So I'll go kind of quick through these ones. First of all, starting with stating names for different planes. So a plane is defined by 3 points, and if we want to name it, we want to pick 3 non-collinear points. So with this first one, state 2 names for the horizontal plane. P is not a point. P is one of the names of the plane. So I can simply put plane P, and I can also define it by using 3 points that are on that plane. So you could also call it plane, and that is HCI. And then we can use any letter or any arrangement of those letters. Determine the intersection of the 2 planes. So something I mentioned is that the intersection of 2 lines is a point. The intersection of 2 planes is a line. So every point on this line, since the line is going to go in infinite directions, the plane will as well. So every point on this line represents an intersection of the 2 planes. Therefore, the line HI, and then I need to put the little line over the top. I can also call this line IH. That line is the intersection of those 2 planes, planes R and P. A pair of skew lines. So I only see one line drawn on here, but that doesn't mean that I can't draw more. So I'm going to pick any 2 points, basically, such as D and H. Okay, and we're going to pretend that my line is actually straight. And if I pick point DH, and let's say I pick, and this one's probably hard to see, use your imagination, I'm going to use point EI. Okay, that was horrible, that line. Okay, let's start up here. I'm going to go right through EI. Now it looks like these are going to intersect. But let's talk about what skew means. Skew lines mean, first of all, that they are not parallel. So that is definitely the case with these 2. They're going in different directions. The second thing, they are non-coplanar. So let's take a look. The red line that I drew belongs to the horizontal plane. The green line belongs to the vertical plane, R. So this green line is going to keep going up and down. This red one's going to kind of shoot off into space going left and right. So you really got to use your imagination to imagine if I really turn this picture sideways, we got one of these coming down more of a horizontal kind of line, and this one would be a vertical line if I kept these planes going. Which brings me to the last point then, and that is that they are not intersecting. Skew lines never will intersect because they are on these different planes, not parallel. They can't belong to the same plane, and they will never touch. So this line is going to keep going horizontally. This other one is behind it. So imagine, I don't know, let's just say there was a distance between these 2 points. Well, there is a distance, but I want you to really imagine this distance between these 2 points. This line is going to keep going up and down, and it is never going to cross this other line. So that is an example of what skew lines are. If I would have said HD, I could not say CD, because CD and HD actually do intersect at point D, and they belong to the same plane. So those would not be an example of skew lines. Let's take a look. We are going to analyze this diagram first, and first thing we're going to do is talk about opposite rays. So a ray is an endpoint that we define, and in the other direction of the endpoint, or the other direction would be a line, not a segment, but an actual line. So a ray looks something like this. Opposite rays mean that I have 2 rays that are going to face in the opposite direction, except they have to share the same endpoint. So when I have 2 rays in opposite directions that have the same endpoint, it basically makes a line. So a ray is defined as having an endpoint, and then you need to determine that direction by using or stating another point. So if I did the same thing going in the opposite direction, and again I move this on top of here, vocab term, these points are on the same line. These are what we would call collinear. Okay, and that actually looks like one of these questions. So First thing I'm going to do is name a pair of opposite rays. So that could be like, okay, let's pretend that F is an endpoint, and I'm going to go in this direction. I would call that ray FE, and I could also call that same ray EF, except if that's the case, notice that E has the arrow and F is the endpoint. I would have to flip my little ray symbol around on the top. So that one and the ray that's going in the opposite direction, two names for that. I could either call it FC or I could call it FG, since G is, part of this infinite line direction, and it wouldn't matter. As long as your endpoint is defined and you use the right direction of the arrow at the top. So again, pointing to the right, I could also say CF, pointing to the left, but that would be an example of opposite rays. Supplementary angles. So that could be any angles that are on a line. So for example, if I had a line that had 3 different angle measures and I called this angle 1, angle 2, and angle 3, I know that angle 1, 2, and 3 are all on the same line. They make the entire line, so they're going to add up to 180. So we want to look for a pair of supplementary angles, and that would also be referred to then, since I'm only picking 2 angles, that would also be referred to as a linear pair. Basically saying 2 angles on a line. So I'm going to take a look at this angle, and that is angle ABF. And I could also call that angle FBA if you were to flip the order, as long as B is in the middle, since B is the vertex point. And I also want to name then the angle starting where my cursor is going through B and in this direction. I know that these 2 angles basically make a line. So ABF and angle FBC are supplementary angles. And since they share that common side, there's a third name for them. So 2 angles that have the same endpoint that also share a common side are also called adjacent angles. Alright, name a pair of vertical angles. So vertical angles, 2 angles created by intersecting lines. So I could call this angle 1 and angle 2. Those are vertical angles. I could call this angle 3 and this one angle 4. Those are vertical angles. If I look at just angles 1 and 3, that is a linear pair, they are supplementary, they are adjacent, all that good stuff. So those are the angles that are created just from intersecting lines. So we just basically have to pick 2 intersecting lines. I will just focus on this angle here, and I'm going to call that angle 1, and I'm going to call this angle 2, since they are created by this line intersecting this line. So I want to name angle 1. So pick 3 letters basically that make up that angle. So angle 1, I'm going to call that angle FCB, and that is going to be vertical with this angle, which is, the way that I drew it, would be DCG. So 2 angles that are basically opposites of each other that actually do have the same measure. So I could also conclude that angle 1 is congruent to angle 2. And then lastly, we are going to talk about, and we already mentioned this really, 3 collinear points. We're really just looking for any 3 points that are on the same line. So if I'm looking at this line that's going up this way, I have point B, point C, and point D. Those are collinear points. So point B, point C, point D are collinear. I could also go a step further and say that the ray CB and the ray CD are opposite rays. And that is also true, which goes back to what I did at the very top. Alright, going on to a little thing called the angle addition postulate. We have 2 adjacent angles, again by definition, sharing the same endpoint. I have 2 angles that also share the same side, which is DB. It's kind of straight. Alright, so I'm saying that the measure of angle ADC, so the ginormous angle here, is 65 degrees. I want to find the measure of angle BDC, so this one right here. So that's what I want to find. Well, again, I said that the 2 parts are going to add up to the whole angle. So what I'm basically doing, 65, my bad. So what I'm basically doing is just taking the first angle and I'm adding that second angle, and that is going to sum to the 65 degrees. So a little bit of algebra, we just want to solve this. X plus 2x is 3x. Combining like terms, I have 19 plus 7, which is 26. And that is equal to 65, and then 3x equals 65 minus 26, which is 39. And then divide both sides, so x comes out to 13. So again, I'm not done there because I want to determine the measure of angle BDC. So the measure of angle BDC, and what we're going to do is just take this expression, which is 2x plus 19, and in for the x, I'm going to substitute my value of 13. So 2 times 13 is 26. I'm going to add 19 to that, which tells me that the measure of angle BDC is 26 plus 19, which is 45 degrees. So this one's 45. If I really wanted to check my work, I could take my value of 13, substitute it up top. 13 plus 7 is 20. Notice that the sum of my two angles would come out to 65. Pretty cool. Alright, I think it's cool. I'm weird. Alright, next one, we want to determine the length of AC. So first thing, I'm going to make a conclusion here because of my little congruent marks that segment AB is congruent to segment BC, and that's because B is the midpoint. So B is going to cut that segment basically right in half. That's what creates the two congruent segments, and what that means is that the 3x plus 4 segment is equal to the 5x minus 6 segment. So that creates an equation. 3x plus 4 is equal to 5x plus minus 6. So don't get what I call 180 happy and be like, oh, these are two expressions that are on the same line. I'm going to add them together and set them equal to 180. These are not angles. These are segments. So they don't make up angles. I agree they are on the same line. A, B, and C are collinear points, but these are not angles. So be really thoughtful and careful in your process. That again, you're identifying these key facts at first, which is talking about congruent segments being equal. It has nothing to do with 180. So what I'm going to do is solve this. I'm going to subtract 3x on both sides first. So I have 4 equals 2x minus 6. I'm going to add the 6 to both sides. And then I'm going to divide here. So my x value is 5. Now, I mean, x is useful, but it's not the end of the problem. We want to find AC. So, since I know these segments are equal, I don't have to substitute 5 in for both. I can really just substitute it in for one of them, and if that's one distance, I just have to double it to get the entire distance. So I'm going to basically solve for the distance from point A to B by taking my x value of 5 and substituting it into that expression. 3 times 5 is 15. 15 plus 4 is 19. That tells me this segment is 19. This segment must also be 19. Therefore, the distance from A to C then is going to be 38. Alright, so if I were to take basically the 19 times 2, I know that AC, or I should say the measure of AC equals 38 units. Alright. Next one, so taking a look at the diagram, I know that this line TG intersects line CD. A is my intersection point. I have two angles that are across from each other. So my key here is that these are vertical angles. Vertical angles are congruent. So I know that angle TAC is going to be congruent to angle GAD. Wow. DAG. GAD, same thing. With AB in the middle. So because these two angles are congruent, they are, just like in the last problem, equal to each other. So I'm going to end up with an equation that I want to solve by subtracting 7x first on both sides. Watch your signs here. 5x minus 7x, negative 2x. You are bringing down the negative 20. It would be really weird if you had a negative angle measure. So x is going to come out to positive 10 here. What we are solving for is angle CAG. So we actually want this one. What I'm going to do first then is take my x value and let's figure out what we do know. I know that if I take my 10 and I substitute it in here, I'm going to end up with 5 times 10, which is 50 degrees. So I know that angle TAC is 50. This one is also 50. So what I want to do is just not even focus on this bottom half of the diagram right now. If I know that this angle right here is 50 degrees, these two angles are supplementary. So this one, CAG, just for the sake of argument, I'm going to call that Y. I know that 50 in the Y value that I just made up those are going to add up to 180 because they are a linear pair, they are adjacent, they are supplementary. So I know that if I take the measure of angle CAG and I add 50, I'm going to get 180 degrees. That tells me that the measure of angle CAG equals 130 degrees. Alright, next one. This diagram is overwhelming. I'm already having a panic attack. There's a lot of stuff going on here. I got a couple of intersecting lines. I have a ray just shooting out from point E going in the direction of F. Take deep breaths. First key term that the key term that I have not mentioned yet that comes up in this diagram is that I have a right angle here. If, not saying I'm doing that right now, but if I were to break this up, two angles that add up to 90 are called complementary angles. And that will come up in this problem, but I just wanted to mention that first. But notice that I have vertical angles here, two angles across from each other. I'm given my 60. What I basically want to find is this x value. So I'm going to kind of forget about this part of the line right now, and I'm really going to focus on this diagram that we have. I know that this part is 90. Angle CEF is 90. And that angle and FED are on the same line. So if this is 90, this whole part has to also add up to 180 then, which means that this whole angle right here is also 90 degrees. Because my 90 here and this 90 would add up to 180. Now, going back to what I said a second ago, because these two angles, the 60 and the x, add up to 90, they are called complementary angles. So complementary angles, any two angles that sum to 180, or to sum to 90. So what I'm basically going to do is take my x plus my 60, set it equal to 90. Easy as it gets, just subtract on both sides. X is 30 degrees then. Okay, if I wanted to keep going, I could figure out all the other angles on this diagram. This one's 30. This is a vertical angle, that's also 30. And then we know that this 30 and this measure right here, which I know is going to be 150, because they are supplementary, they're on a line, they're also going to add up to 180. Okay, so a lot of different ways. We could also even take a look at the relationship between EAD, and I could take a look at BEC. These are vertical angles. 90 plus 60 also equals 150. Alright, last thing then. Going over distance and midpoint. Throw the distance up here, which again is basically Pythagorean theorem. So my distance formula says if I find the horizontal distance between 2 points, basically saying, okay, in a triangle, if I were to look at the distance left to right, that is my horizontal distance, x2 minus x1. And in the Pythagorean theorem, we always called that a. We said a squared, plus the vertical distance, y2 minus y1, so subtracting the y coordinates, we always said a squared plus b squared, and we always set that equal to, and in this case, c, but I'm going to call it d for distance, but we always set it equal to that value squared. A squared plus b squared equals c squared. Notice the d is isolated here, and that's because I already applied the square root to both sides. Therefore, this formula that I have up there is the distance formula. The other formula we're going to use is midpoint. So if I had two numbers, I'm just going to throw this out here. If I had a value of 7 and I had a value of 20, and I wanted to find the middle of these numbers right away. Well, middle meaning the average would be your mean. I could add the numbers together, divide by 2. That'd be like 27 divided by 2. And then that would tell me 13.5 is right in the middle of both numbers. So the same thing would be used logically as far as coordinates go. I know that my midpoint, xy, is equal to, I'm going to make a giant coordinate. If you averaged your x values, you took x1 plus x2 and divided by 2, so averaging the x's and averaging the y's, you would end up with the middle of two things. So again, this one is midpoint, and this one is distance. So both those formulas are going to be helpful in this problem. It says T, which is a point at -4, -6, is the midpoint of segment PQ, which has an endpoint. One of the endpoints is Q, 2, -8. We want to determine the other endpoint, basically. So just to give you an idea of what this problem is saying, is we have Q is somewhere here. I know T is somewhere in the middle. We don't know where the heck P is. It's out there somewhere, but we need to find it. So T is the midpoint. So I'm going to start by substituting some values like into this equation. The x part is -4. So I'm going to take that -4, and I know that -4 is going to be the average between this 2 and whatever x value we have from p. So I'm going to just call that x2. I'm going to do the same thing then for my y values. I know that my -6 is the average between this -8 and whatever my other y value is. So what I want to do is solve these. This 2 plus x2 expression is being divided by 2, so I'm going to bring this over by multiplying it. -4 times the 2 is -8. That is equal to 2 plus x2. I'm going to solve then. x2 would be -8 minus 2, which is -10. Do the same solving here. That's going to give me -12 equals -8 plus y2. And then if I added 8 to both sides, I would get y2 equals -12 plus 8, which is -4. That tells me that my other endpoint, and I'm going to just write it up here then, my other endpoint P must be located at -10, -4. So I'm going to wipe some of this logic here. If you missed that, anything on this video, pause, rewind, fast forward. So I have that up here. What I want to now do is find the length of PQ. So Q is located at 2, -8. If you travel from P to Q, it's going to give you the same distance if you travel from Q to P. So it doesn't matter what order you put your points in here. Just make sure you're lining up your X's and you're lining up your Y's. So if I call this value x1, y1, and I call this x2, y2, we can sub those into my equation and get our distance. So I'm going to set it up. D equals the square root, and I'm just going to make the formula first here. And now I'm going to start by substituting some values in. So if I take x2 minus x1, and then my y2 minus y1. So just be very careful on your signs of these things, especially with entering into your calculator. -10 minus 2 is -12. And then we have our -4 plus -8. That's going to come out to +4. So this is where you really got to be careful when you enter this in your calculator. If you just type in -12 squared without putting the -12 in parentheses, your calculator is going to say -144. So make sure you realize that when you square a negative value, it becomes positive, which means you have to put that -12 in parentheses. You're going to end up with 144 plus 16. So I'm going to end up with my answer being the square root of 160. And what we want to do then, it says we want to round to 2 decimals. So I'm going to take the square root of 160, which is approximately 12.65. And that would indicate that that is my distance between those 2 points. And that is the end of our problems. So quick recap on all this stuff going from the top. We talked about intersecting planes, skew lines, supplementary angles, vertical, different types of points, rays. We talked about angle pair relationships, 2 angles being adjacent, using the angle addition postulate. We talked about midpoint. We looked at vertical angles and we did some algebra. We looked at complementary angles, and then lastly we finished with distance formula and midpoint.